This is question number 7 from the SACE Stage 2 Physics course companion from the Cyclotron chapter. Here we have a cyclotron with an operating voltage of 3.5 kilovolts and it has a magnetic field strength of 1.8 Tesla. There is a 30 millimeter gap between the Ds and the proton is accelerated by the cyclotron. First we need to calculate the energy gained by the proton as it passes through the gap. So here, just using work done equals change in energy, which is Q delta V. Charge of a proton is the same as the charge of an electron with a different sign, so 1.6 times 10 to the power of minus 19. And the voltage here is 3.5 kilovolts, remembering to put in that kilo factor. So 10 to the power of 3, and if we multiply that together we get 5.6 times 10 to the power of minus 16 joules. That's fairly easy. Part B, we need to calculate the magnitude of the electric field between the gaps. So here, just using E equals delta V on D, remembering this is a different E to the one in the question above. So here we have the voltage is 3.5 kilovolts. And the distance between the gap is 30 millimeters, so remembering to include the scale factor of 10 to the minus 3. And if we substitute that into our calculator, we get 1.17 times 10 to the power of 5 volts per meter, which will make 1.2 to keep the correct number of significant figures. Part C, we need to calculate the period of the motion of the proton. So here, again, this is using a fairly straightforward formula. We have T equals 2 pi m on QB. Everything we know is in the question. So here, 2 pi is 2 pi. Mass of a proton, 1.67 times 10 to the power of minus 27. The charge, as we said, is just 1.6 times 10 to the power of minus 19. And the magnetic field strength in the question was 1.8. And if we substitute that into our calculator, we get 3.64 times 10 to the power of minus 8 seconds, which we'll write as 3.6 times 10 to the power of minus 8 seconds. So that's a straightforward substitution. And the last question, we have to work out the final kinetic energy of the proton, given that the cyclotron has a radius of 45 centimeters. So here, just using the relationship, E is Q squared, B squared, R squared, all over 2m. All of these things were given in the question, so charge is just the same as before. Magnetic field strength is the same as before. Now the radius is 45 centimeters. We need to convert that to meters. So 0.45 squared multiplied by mass of the proton, which we're given 1.67 times 10 to the power of minus 27 kilograms. And substituting that into our calculator, we get 5 times 10 to the power of minus 12 joules. And that's it. All of these parts were just straightforward calculations, no rearrangement or anything like that. Very straightforward, and yeah, should have been fairly easy. I hope you enjoyed that.